Okay, so in this case here, we asked to solve this, okay, with our range. And the range is what I want us to focus on to begin with. Fact is, they're asking for solutions of x between 0 and 180, okay? But when I do sine to the minus 1 in a minute to work out the angle of this, all right, it'll be for this result here, yeah, 2x minus 75. And you've got to appreciate x, that's what we've got here with our range. Our result though for sine to the minus 1 of this will be for 2x minus 75. So what I'm going to do, I'm going to adapt my range, okay, so I'm going to get all the solutions then that I need, okay, because I do need to get all these solutions that they're asking for between 0 and 180. So if I adapt my range to this, so first of all I'll go for 2x, which means I'm doubling x, yeah, so I'll double this, I get 360, and I'll double 0, I'll get 0. So that's 2x, and then I'm going to do minus 75. So 2x minus 75. So essentially, I'll have 360 minus 75 here, and I'll have 0 minus 75 here. So take 75 away from both of them. So I get 2x minus 75 is less than or equal to, in that case, 285 minus 75. So when I draw my graph, it's got to be between these values here. Okay? So let's work out what that angle is. Sine to the minus 1 of minus 0.515. Okay, so my calculator, it comes out to be, well, you can see when you see the display here, right, it's like basically 31, isn't it, or minus 31 when you round it. So we can put that down there, right, minus 31 degrees to the nearest whole, right? Okay, so then what we can do with this then is draw our sine graph. Okay, now remember, sine graph has to go between these values here. That's our range. Now, I'm not going to go to minus 75, right? I'm going to go to minus 90 because I can't really stop my graph at minus 75. Okay, so we go to minus 90, which makes a lot of sense. So go up in every 3 centimeters. So that'll be 90, that'll be 180, that'll be 270, that'll be 3, I'll go up to 360, right? Because they're 270, I need to go up to 285, but I'm not going to stop halfway or whatever, so I'll go all the way to 360, okay? And continue that little axis along there a little bit. Okay, so minus 90, 0, 180, no, 90 here, what am I talking about? 180 here, 270 there, 360 there, okay? We'll have 1 here and minus 1 down there. So we're going to plot our points. Sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1, sine 360 is 0, and sine minus 90 is minus 1. So when you draw your sine graph, okay, remember now it's a wave, right? So you can't do straight lines. But setting up the scale like I did there, measuring it out, will actually help you with the drawing. Now, we've worked out that, haven't we, sine inverse of that, which is basically minus a half, isn't it? So that's about there. Okay, and we'll draw a line through there. And you can see my first result here, which was minus 31. But I'll get 2 other results here and here. Okay, so I've got minus 31 here. To get that result, just think of the symmetry, because you go in that way, across 31, we'll go in this way, you'll go across 31, so 180 plus 31. And the same here, 360, you go in this way, so you're going to go back 31. Now remember, this result that we worked out here, sine inverse of this, was basically for 2x minus 75, wasn't it? And that's what I set my range on. So 2x minus 75 are what these solutions are for. Okay, to get x, I need to then adjust this then. They want x, remember, so I need to take that minus 75 over and add. Okay, so that will be, what was that, 211 there, add the 75, and that there'll be 329, add the 75. So then 2x will be, this works, that'll be 44 there, that will be 286. And that would be 404, yeah? And then, last but not least, I'm going to divide by 2, so I get 22. that would be then 143, and that would be 202. So there's my solutions. And don't forget then, of course, it's got to be between 0 and 180, so you can actually dismiss that last one because it's outside the range.